Hello there, it's me Prot, and today I'm going to stream the same thing that I'm streaming every stream, every week, couple times a week. So this is a renderer for Half-Life 2 maps and other source games, which renders only static geometry, but it also supports loading multiple levels at once. It connects all the levels which it can extract landmark information for to position correctly. And so it does load a lot of stuff. Some stuff is positioned wrongly, but I'm still happy with current state that it basically works. Last time we fixed a lot of missing textures and corrupted textures, stuff like that, and also tried to load maps from episode 1, episode 2 and Portal. Basically it works. There was some rendering glitch on episode 1 that I don't know the reason for, but basically it works. And as you can see, I fixed chat, so chat should be displayed. I I will also be speaking in really bad English as always, because it's not my native language and it's difficult for me to do anything right. So today's plan is to optimize rendering. As you can see, it's really slow. FPS is like 5 or something, and I don't think that it should be this way. And there are ways to optimize it. Yeah, but first we'll need to fix profiler because it... Let me show you. Like, this is bogus. Like, it tells me that FPS is like 500 or something. It's obviously not correct, and the total triangles jumps all the time for no reason. Like, what? So there's something going there that I don't understand. So yeah, everything seems to be fine, I believe. If there are any issues with the stream, please let me know. And the music that's playing is Demo Vibes 3. We have a lot of demo vibes set to go. This is basically demo scene music from early notice. So yeah, let me just start making mistakes and comments things. So first thing that I want to address is the total triangles number. Because I have no idea why it might end up being so unreliable as a number. So let me just check. The interesting thing that for one map from can I do something like this? Yes, thanks. For one map it's stable and everything seems to be fine. Like those numbers are reliable. I really do have a like this is the refresh rate. If I do like 32 maps. Yeah, this happens. What's interesting is that those numbers do no, they don't always replicate. Like, what the hell is going on? Map model. What is map? Gmaps begin, map loaded. Oh yeah, it's totally understandable what's going on here. Okay, so basically this is a loop for that renders all the maps, but for some reason I do profiling on inside this loop, while the frame is actually this entire function. And what I need to do here is to do this. And output the number here. Yeah, let me try it at this. Okay, this looks more like it. So this is a really crappy profiler that I quickly wrote like in an hour for this thing to be to profile it running on Raspberry Pi. Like I really hacked something together really quickly. And so the basic idea, it measures the time, frame time. It's around 55 milliseconds per frame, and the frames per second like 18 or something, and which is really low. And then it measures some functions, OpenGL functions, how many calls per frame are made for each function, and how much time each function takes to execute. So these are really per map, and they don't really take much time. I believe the time here is microseconds. Yeah, it's microsecond per frame, average microsecond per frame taken by this function. Right. Yeah, it seems like it. Interesting. Геккерка, привет. Не то чтобы поздно вечером, ну, в 11 часов. У меня обычно запланировано на 10, но не получается. Я думаю, на самом деле, вообще переносить на 11 или на полночь по новосибирскому времени. То есть еще на час позже, потому что не получается начинать вовремя, и есть моменты, которые я хочу перед стримом успеть сделать. Я, например, сегодня чат пофиксил. Чат, ура, есть чат. Критью, привет. Z-файтинг глупый. Вот здесь вот. Okay, so this data seems right. So there are around 16, almost 17,000 bin texture calls per frame, and the same amount of uniforms, and almost 18,000 draw calls. This is insane. This is an insane amount of draw calls. So, and draws take so there's average 2 microseconds per draw call, and maximum like 1 millisecond per draw call. I thought 3 milliseconds, but the sheer amount of them generates this huge number. Maybe if I was making a Vulkan Ranger, I could optimize something on this level, but I really want to keep it on the OpenGL ES level API. На OpenGL с DX12. А почему на OpenGL, почему не на Vulkan? И как жить стало веселее? So 7 milliseconds there, 3 milliseconds on GL uniform. So the main thing that I want to optimize here is amount of OpenGL calls, draw calls, and let me think aloud about it. So basically, each level, плеер, привет, на заметку, стрим на ГГ не работает. Спасибо за информацию, интересно почему. Но я вижу, что здесь он как-то работает. Странно. У меня вроде работает. The renderer. Basically, each level currently. Okay, maybe I should start drawing. And for drawing, I need this tab, and I need this thing to start drawing. Okay, I'm still not used to this tablet thing. So basically, each level loads into this giant vertex buffer array. So the entire level geometry is basically this vertex buffer object, which consists like each vertex is something like this coordinates, and each vertex is like position, and I believe light map UV, light map texture coordinates, and texture UV, the material texture coordinates. And I really want to extend this at some point to be able to do detail textures, normal, stuff like that. Не знаю, мне не запускается, смотрю с YouTube. Ну, спасибо за информацию, но я, видимо, потом проверю, потому что у меня просто все... Я ткнул на play, оно заработало. Странно, странно. This is a vertex. Then, like, this is a BSP structure that BSP parser emits. It emits this object and a list of draws, so-called BSP draw. BSP draw is a thing that that specifies material, and material itself specifies texture and probably many other things, but currently many things are not there. В TX12 очень много операций для управления ресурсами и ошибку там найти сложнее, чем в OGL с N-сайт отладчиком. Плюс TX12 работу не найти. Уже все пороги отбил. Миру, наверное, не нужно такое количество rendering engineers. Вообще, наверное, да, у нас на родине, так скажем, с рендерингом не очень хорошо. Ну, мало работ, мало ребят, которые занимаются рендерингом. Действительно. Learn OpenGL хороший, да. Вот мне, наверное, самому надо его перечитать. Может, тоже узнаю что-нибудь новое и интересное. Anyway, material, texture, and some other things that maybe I will add in the future. And it also specifies yeah, there's another thing. This is BSP draw, this is BSP. I believe, let me check, I forgot the renderer. SRC, BSP draw material. Yeah, material, this stuff, VB offset. BSP model. Yeah, IBO. There's this common IBO object that I really need to cram somewhere here. IBO, index buffer object. So this is indices, and they are 16-bit. And this thing basically references the BSP draw at this point, references some sub-range of the IBO, which is this start and count. Start and count. This is start, this is count. And also specifies an offset into IBO. I'm really not used to writing start and count. And it also specifies VBO offset, which tells the IBO at which position will 16-bit indices will reference the VBO. So basically this thing contains number which reference vertices here, and they can be scattered all over the place. But this offset specifies the number at which the vertex that is base vertex for these references. So it allows the IBO here to reference vertices larger than 64K. Как хранить координаты текстуры, если там индексы используются? Координаты текстуры — это просто флоты. Текстура — это отдельная штука здесь. Так. Индексы только референсят вершины здесь. So yeah, and this thing, this is basically the renderer, the structure, data structure for rendering. Really simple, like trivial, the simplest thing that you can come up with. And there are many of those. So there are per vertex VBOs. Per map VBOs, per map IBOs, and a lot of draw calls per map. And yeah, another thing that BSP draw are sorted by texture. So so let me draw it again. Okay, so like these and these are here are multiple BSP draws, but they are for the same material. So same material, multiple draws. And this thing actually, the renderer here actually leverages this sorting, so it concatenates by this thing here. It concatenates many adjacent draw calls into a single draw call, because it can just say that, okay, starting here, there are so many indices, and indices are triangle list, not triangle strip or anything, because they basically the data in maps that I looked at contained a lot of small surfaces that are like don't benefit from triangle list or fan, triangle strip or fan or something. Basically, a triangle list is the best not the best, but like there's no point doing other thing. And doing triangle list allows me to do this concatenation here. My handwriting is really horrible. ВБО хранит только точкой, а индексы используются для сборки треугольников. И там же, наверное, должны храниться координаты текстур, но уже вроде нельзя управлять форматом элемент буфер. Нет, координаты текстур хранятся в ВБО. Причем, на самом деле, чуть хитрее. Можно их распекать по-разному в ВБО. То есть одна вершина может использовать компоненты, вот эти, там, позицию, координаты текстур или еще любые рандомные штуки, которые можно придумать. Она может хранить их в отдельных ВБОшках или просто в памяти. Этот этап случается на этапе биндинга, вот связывание этих атрибутов, которые попадают в шейдер, происходит на этапе биндинга vertex, там что-то там, как же называется-то, атрибутов. Вот эта вот штука, вот это вот что биндит. Я рассказывал на прошлом стриме. Или позапрошлом. По-моему, на прошлом. Can I do anything about optimizing this? So the idea number one, like the first idea that comes to mind is that the core problem is that I have too many draw calls per the entire map thing. The first idea that I have is what if I just, you know, concatenate all the maps into single VBO and single IBO, and then just sort all of this stuff into so after loading, I do this entire thing and sort all the stuff by same material, by materials, and yeah. Yeah, another thing is that this can be broken by the stuff VBO set, because this actually happens only for a handful of maps. So there are just like 3 or 5 maps that have more than 65 vertices. А если на клиенте памяти не хватает для такого большого буфера? Вообще хватит, потому что, ну то есть оно же вот здесь вот есть, это все просто куча маленьких буферов. Можно точно так же спокойно совершенно засунуть все и в один большой буфер. Это не проблема. And we have like 750,000 vertices, triangles for this thing, which is cool. And that amount of triangles shouldn't result in such low FPS by itself. Like, I believe modern games have several millions triangles per frame. And they do a lot more complicated rendering, sophisticated. While I just read the texture and output its color. Well, read to texture, multiply their colors. This could be actually done with fixed punch function, I think. Okay, so think that this can be broken by this VBO offset. So if some later thing references vertices more beyond this limit, it will get... Да, это Фарбрауш, это этот самый Poem to a Horse, по-моему. 64К какой-то там 2001 или 2002 год, что-то такое. Okay, and like this, okay, merge all maps into single VBO plus IBO. And the problem here is that I will need to actually sort VBO. Okay, okay, on the plus side, reuse no render C changes. This can be like the same stuff. On the minus side, I will need to sort vertices by material 2. And also on the minus side, we'll still render far maps for quality. So the thing that I really want to do here is actually to be able to draw this entire mesh on Raspberry Pi. I'm not sure that I will be able to do that, but I really want to do that too, at least to try it. And this thing will, I believe it will be still too complicated for the rendering. And here comes option 2. Like, this can be done, but just like I don't like this problem, and well, yeah. And the option 2 is to do basically do lots, level of details, where let me show you by example. What? So this level here is really close, and it should be rendered in full quality because it's visible, and yeah, if I get to support models, which I won't, but I'm not sure that I will be able to do, I could also render models on this level because it will be prettier that way. But for example, this level here doesn't require any complicated things, and for some faraway levels there are only barely visible, like only a few hundred pixels per level. And I really think that I could get away with like not rendering it in with full material textures, or even maybe light map textures. So maybe I could just draw the nearest visible levels in full detail, and faraway levels basically an entire level, the whole level, using one draw call. And that way I could do under 1,000 draw calls, even just a couple of hundred. Я, кстати, сейчас пишу свой загрузчик модели из ID, it engine и GoldSRC. Позже, думаю, и BSP загрузчик нужно будет писать. Ну, круто, желаю удачи. Это нормально. GoldSRC. Кстати, GoldSRC. Вот если делать этот самый OpenSource и BlueShift, то там нужно будет поддерживать GoldSRC, потому что они не портанули их на Source, не сделали ремастер на Source движке, и я пробовал смотреть, ну так, краем глаза, могу ли я загрузить их карты, там совсем другой формат. Ну, не то чтобы он прям совсем другой, но из коробки моя тулза их не поднимает. Вот. Так что там нужно будет тоже почитать, разобраться, как устроено. Кринтю пишет: недавно пробовал запустить твой рендер на первой малинке. Bus error. Да, это известная проблема. Я собираюсь ее починить. Она у меня даже где-то записана в планировании. Кстати, мы это вот сейчас сделаем. Basically, there is this problem that currently this utility doesn't work on Raspberry Pi because the stack, the memory allocation that I do, which my own like pre-allocated stacks, doesn't return aligned memory for a few reasons, because it supports like allocating many sequential objects, tightly packed sequential objects, and this is the default mode of operation. And fixing the crash on Raspberry Pi requires to like have two separate modes for the stack allocation, aligned and not aligned. I do plan to address that sometime soon, probably before macOS support, and probably before alpha channel for textures. So yeah, it seems like this is the next thing for me to do after I fix my position. Yeah, probably next week. Было бы хорошо дальние объекты сначала перед рендерингом превращать в низкополигональные. Вот это я, наверное, не стал бы делать, потому что, вообще говоря, как это ни странно, это не очень простая проблема. Вот, уменьшение детализации полигональных моделей, это так как бы репу почесать на самом деле. Но не то чтобы уверен, что какое-то общее решение этой штуки существует. На GitHub сделали доски, да. So what I'm proposing here is to, as a optimization for rendering, is to have two levels of details for a map. The first level of detail will have this the detail geometry basically, and second level of detail will have only a single or like a couple draw calls if the level is too, how do I say it, if there are too many vertices in this level, so I have to split it, do it at 16-bit indices requirement, limitation. So yeah, and then in runtime I can do many things actually. I can first thing that I can do is to let me just open this thing, not this one, but this one. Скрам-доски. Тут можно на GitHub создавать проекты и вот в них вот так вот раскидывать. Я тоже недавно узнал. So, map first I'm calling. So there are several ideas, like map first I'm calling. What if I just don't render the invisible maps? This is an optimization, but as you can see, at this camera position, I do see the entire all the maps, and it wouldn't work. It wouldn't optimize anything. Face first I'm calling the same thing, but more complicated, because I will need to pick draw calls or even generate draw calls at runtime, which is like I'm not sure that under these requirements is a good idea. BSP node first or PVS calling. This actually for my purposes is complete overkill. Like I don't even need to do that. It can render all this stuff. Dynamic per material batching of visible faces. Yeah, the same thing basically. Just technical support for this or for this. Pre-sort vertices by material for VBO offsets 64K splitting. Vertices by this is something close to this thing, worded in a different way. In one giant VBO for the entire mesh. Yeah, these are this is a couple. Skip material and light map textures for distant map. No, do bait colors instead. Yeah, this is basically what I'm talking about. Combine most popular regular material and texture in the atlases to avoid splitting draw calls. This is also interesting to a degree. Can I do... And this would require additional... First of all, this would make MIP maps complicated. Because I will need to handle, like, what if textures are different sizes, and I will certainly need to do wrapping and repeating textures manually in shader. Фарообрезку в камере. Фарообрезка в камере нет, потому что я хочу видеть всю геометрию всего Half-Life за раз. PVS либо BSP карты видимости не хранятся в BSP файле. Хранятся. Они хранятся, их можно загружать, просто они здесь не нужны, потому что я хочу видеть сразу все, оно не может отрезаться. То есть оно может отрезаться, когда я нахожусь где-нибудь здесь внутри. То есть вот здесь, да, я могу по ПВС и по... Ну, то есть по BSP посчитать, в какой ноде я нахожусь, и по ПВС вырезать все невидимые ноды. И выбрать себе поверхности для рендеринга. Но это не основной режим работы этой тулзы, он бессмысленный. Основной режим работы этой тулзы — это вот так вот летать везде. И вот этот случай нужно оптимизировать, чтобы он был с высоким FPS. И здесь есть вот это инсайт про то, что инсайт, как бы наблюдение просто, да, что даже в этом режиме, как правило, всего 1 или 2 уровня находится близко к камере в достаточной степени для того, чтобы отрисовывать полноценно всю геометрию уровня. So yeah, I want to do this. I want to do this thing, and it will also require, as I will have dynamic rendering. So okay, there are several things to address. First thing that I want to do is change the output format for the BSP. So BSP model. Bounding box, light map, EBO, IBO, draw count, draws. So another level of, not in direction, but structurally, this becomes this is really cool music. This is, I believe, from this is an old demo from Sunflower or something. Let me actually check it. Yeah, so this. I remember this. This is cool. Okay. BSP draw set. And this thing is basically this. And I have several of these. Можно свой ПВС и БСП сгенерировать перед запуском основного рендеринга. Можно, но зачем? То есть, еще раз, проблема не в отсечь то, что невидимо, а в том, чтобы нарисовать все наиболее эффективно. Потому что количество на самом деле невидимой геометрии, которая, например, спрятана за какой-то другой, здесь не очень много. То есть она в каком-то виде есть, а основная проблема, что ее типа много мелкой на расстоянии. И единственное, что я могу сделать без какого-то изменения самой геометрии, ну такое, типа самое ближайшее, что я могу сделать, это именно что просто выключать фичи и рисовать там всю карту за один draw call. Что-то делать с самой геометрией — это следующий шаг, и я просто надеюсь, что до него не дойдет. Draw set tailed and strong BSP draw set. Course. Fine and course, whatever. And now this thing needs to support outputting both kinds of geometry. Another interesting thing is that basically the coarse geometry doesn't even need to have the same vertex format, because it needs only vertex light map UV, probably light map only, and it doesn't need normal or text UV, but it would probably need like average color for the material texture, which is really interesting because can I reuse this vertex? I can reuse like normal for this grab. Okay, so let's start first. First by model light maps, no, it's not it. Load displacement. Yeah, another interesting thing is that I could probably avoid generating displacements. I'm not sure. No, it will look bad. I remember how it looks without displacement. It's bad. So yeah, load model draws. It really reuses the same vertices buffer. Ну да, это и есть идея. Далекие объекты рендерить без текстуры и из ВБО брать просто средний цвет. Это как бы такой наколеночный мипмэппинг получается, да? Когда текстура просто сжалась до 1 пикселя. В принципе, в теории, можно даже делать чуть хитрее. Можно запекать несколько характерных цветов текстуры, то есть там 2 на 2 или даже на 4 на 4. И их подсасывать уже в шейдере. Но это тоже следующие шаги, если типа будет плохо выглядеть так. Окей, so I do reuse vertices buffer. I do reuse indices buffer. Well, not exactly. Or yeah, I reuse both of these. I reuse both of these. So how do I do it? Okay, I probably need a separate counter for indices. Because this thing generates a draw per face. Draw per face. Generates draw. You know what? Another thing that I thought about is what I really need to do is to sort faces by material. But I probably can't. Yeah. Another weird thing is that there are too many materials. There are a lot of like single face materials or something like that. Skybox был бы, кстати, да, Skybox стоит в задачах. But I sidestep that to some degree by ignoring many material properties and only paying attention to the texture that material uses, the first texture. And that I can't use for sorting faces, because at face loading stage I don't know anything about material. But maybe or do I? I do know about material in face stage. CTX faces, I face. Yeah, face knows about material. I really can pre-sort faces. And then this entire thing can just go away. I will be limiting faces. Okay, how do I say it? I will be generating draws only for per like a set of faces with the same material. And then this is a bit unclean, I would say, because it leaks information about about efficient rendering to BSP loading basically, but it also kind of there. Just look at this. But it would allow me to completely avoid doing this in render. So render could actually just draw draws without paying attention at what these draws actually do. And it will also generate an efficient VBO where consecutive indices reference consecutive vertices. На многопоток перевести некоторые части кода. Ты заглядываешь в будущее. Это то, что я хочу сделать тоже. Это позволит, во-первых, загружать уровни действительно параллельно там на сколько вот у меня 8 ядер есть. И это будет в 8 раз быстрее, ну там в 7 с копейками. И второй момент, это также шажок технологически в сторону загрузки на лету. То есть можно летать по этой всей фигне, пока она грузится, хотя она там грузиться будет несколько секунд. So the idea here was to use threads for loading, like parallelized loading, and this is a thing that I want to do at some point, but I'm not sure that I will be able to get to that, but as usual, I'm not sure about anything. But yeah, this is actually, I think it's not planned. Or no, I don't have it. Maybe it's like in trash or something. Resource, yeah, I think this is it, resource streaming. This is old thing, but I was like, okay, I probably can reuse that. Okay, yeah, it's like the issue there doesn't really mean what it means for me. It's hard to figure out what I meant by that. So should I invest in sorting for faces at this point? Row count, CDX faces count, stack a log. Probably I want to do that. It will simplify many things. Okay. Let me check a few things here. Okay, what I need to do here is to this, I don't need to do this, I need to do draw indices, start indices, pause. How do I use this? What? I do use this. Okay. So I should start by sorting faces here, which is like to sort. Okay, I forgot the signature again. base number of members in size of a member. Base is CTX faces. Number of members is CTX faces count, and member size is CTX faces. Face material compare, which is a function that I only will write. Static int face material compare, and its signature here is const void a, const void b. Yeah, and it should return material comparison, and for that I really want to consult what rendering does. Optimize draw compare draw compare does this. If a okay, so yeah, I need to cast this to const struct bsp face a and const struct face why I can do just this. Okay, what fb b, and then I can do it like this: if fa material equals to fb material, then return fa material base texture 0 minus fb material base texture 1. And fa material, if material exists and they are the same, not the same, no, they're not the same. If they're not the same, but otherwise, how does this even work? They can have the same material, but like different. What the hell is going on here? Okay, there was a bug here. There was a bug there, and I really want to fix it Okay, I can just avoid doing this at this point and check what was that bug about. Let me try it. So basically I was comparing textures wrong, and now I want to figure out how much difference base material combined defined but not used.
I've got absolutely no fucking reply. He's probably huddling with a TUC.
Does it make a difference? Well, it does make a difference. The bug that I just fixed sped up things significantly. Let's just look at 70, okay, 60 something, and 3000 draw calls and 3000 texture sets. And before loading, the same thing. Okay, the same thing was doing 16. Okay, I do remember that this one was really slow. The entire level. Okay, it's still slow, but not that much. As you can see, it doesn't really depend on the viewport size, so it can be really small, but still slow. It's indeed bound by the draw call count. And yeah, it's significantly lowered the number of draw calls to 5000. VXP сервер, привет. Okay, but I still want to check whether this optimization will make sense. Okay, so the current data is total triangles 1.5 million basically, and I want to remember these. So what is the best way? Like pre-face opt txt. Okay, this one, and let me do this thing that I wanted to do. Yeah, sort faces first. And okay, what I want to do here is to static int PSP create, not create, but load faces to draws. And this one probably needs only const struct faces int num faces count, and struct bsp draw draws. I think this is enough data for it to proceed. And why do I need this function for is I want to do it in 2 stages. Basically, the first stage goes through all phases and gets the amount, the number of draws that it needs to do. And second pass creates, and if there are no draws passed to it, it'll like just return the number of draws that it wants to create. And second pass, then I allocate this number of draws, and second pass will create, will fill the draw data, because it's not easy to figure out the exact number of draws from the number of faces here. And yeah, this goes here, and this is buffer. Okay. So these stages are really slightly more complicated than I thought, because it doesn't just fill the data, it creates the data at this point too. Oh well. Oh, what to do? I really need to face indices data created. So these 2 passes will be really different. The first pass will really create indices buffer, for which we do know the size. Face vertices, face indices, we don't know. And we do need CTX. Okay, so yeah, it becomes slightly more complicated. Oh, okay, well, whatever. Just need 2 of these to pay attention. To look at what I'm doing. You know what? I've been streaming for an hour already. Let me just make a small break, 5 minutes break, and I will return to doing this and optimizing stuff. A short break. How do I do a break? Okay, this. Okay, 5-minute break.
strange happen when you realize that life contains like some situations no longer have your fun, and you know that reason is the only God. You have to follow in the sweet, in the blow. For heaven's sake, for the wind to blow. My soul needs a light to follow.
I just ate an apple that had worms in it, and I wasn't happy about that.
But I've got to know if I'm ready to go. Heaven's not really
Okay. What I was doing here, I needed for these things to do two-pass loading, but I still want to reuse the logic around
Look at us, for example. We're state of the art. Control metabolism,
deciding where to split
brain,
the draw.
cybernetic bodies. Not long ago, this was science fiction.
Vertex buffer, indices buffer. Split draws. So end music ended basically because it only had an hour. So demo vibes 4, here we go. Смотрю с задержкой в 11 минут. Это как... я сейчас оставляю как послание в будущее потомкам. когда-то в стене вскроют там... Окей. What do I need to do here? I need to also pass vertices buffer and indices buffer, but not really. Model draws. Load face. Okay, who calls BSP load face? Not this face. Okay, who calls BSP load model draws? Atlas. Preload faces. Collect light maps for all faces. It collects light maps and it also allocates faces. And it also does this thing that I'm not happy about. It allocates a lot of objects on this stack sequentially. It uses temporary stack. Temporary stack I'm fine with. The thing is when if I will get to doing multi-threaded loading, I will have to serialize access to permanent memory, or have several per thread permanent memory regions, and that I'm not happy about. And I wouldn't be able to allocate several things, adjacent things in persistent memory that way. That's why I'm trying to pre-calculate the number of draws that I need to do.
Now let's go over it once again.
One way to do this is to do it just not care about things, just okay, probably I will do it this way, and well, whatever. Faces count +1. What? What is this crap? Tail it. Draws. Count. You know what? I can just reuse model draws. You don't have draws. You now have detail it draws count 0 and model course draws count
Now let's go over
0.
it once again.
And this thing here really wants to be... it needs... vertices start.
If caught early enough, even a potential
Count 0 and int course vertices count. And what happens here is if model not model, if detailed vertices count plus I face detail vertices is larger than C max draw vertices, then detailed vertices count 0 and model detailed draws count incremented. If course vertices face vertices. Okay, yeah. Well, I face is an int. And this thing is basically this, but with small distinction here that this Гигарка пишет, HDR, TXA, BAU, God Race или еще какие-то эффекты будешь делать для своего движка? Для PBR, наверное, тут материалы не подходят. Для PBR действительно тут, скорее всего, не подходят материалы, то есть, ну, недостаточно просто данных для PBR. Хотя можно там что-то поиграть, попробовать. Эффекты, скорее всего, никакие не буду делать. Я на самом деле хочу что сделать? Я хочу вот это примерно. Это definition of done для этого проекта. Вот это хотелки, которые типа, ну, может быть, хотя вот это, не знаю, это, наверное, в трэше. Нет смысла эти данные, что-то с ними делать. Вот это, может быть, я захочу сделать. Вот это. Скайбоксы у меня тут есть в каком-то виде. Вот это может быть. Ну, то есть... это никогда не починю. Код всегда будет плохой. Шейдер с водой, может быть. Ресурс... Ну вот, короче... Нет. Причем я по-хорошему делаю, то есть вот одну задачу за стрим, да, и это вот сколько еще стримов? Это еще в лучшем случае. Это еще вот на 6 стримов получается. Это слишком много, я хочу пораньше закончить. Побегать, ну побегать. С побегать есть проблема, что оно будет ограничено. Много границ уровней заканчиваются реально стенами. И их нужно будет или вручную вырезать, или что делать. Пострелять и фонарик, и вот мы написали Half-Life 3, да? Ну... So, the thing that I want to check here, if I face isn't equal to... slightly larger than 0, and... this is a group. And face material compare. Sticks faces plus 1 and face isn't equal to 0, or this thing happens. Then split. And we should start with a single draw for each of those. And only add draws if we exceed the limit. And then what we do here is we allocate all those draws. So model, detail draws, detailed, what happened? And the same thing for force. Где побегать? Мануал не припомнишь? Какой мануал? Я не очень понимаю, про что идет речь. Yeah, so this we have done. To generate course draw, what do I need to do? What do I need to do for course draws? View offset vertex pose. Okay. This condition really is this one. X plus minus VB offset. Yeah, something like this. And it also changes like horse. Tell the need to create a draw here, right? And this this is actually different. I really want to do this is the only place where I will allocate a new draw. So here, what do I have? Struct BSP draw. Detail draw. Equal to nothing, and also course draw equal to nothing. And at this point I need to allocate the detailed draw. Not nothing, but how to like do this thing. Start is 0. Count is 0. VBO of set is VBO of set. Material equals to face material. And I can't really do this. I should do it like this. CTX, not CTX model. Detail draw -1 because it will be like detail draw plus detailed draw. So first of all, I will point detail draw to the draw first should draw before the first one, and I will do the same thing for model course draws. And then I will just update this draw count start. Do I need indices start? Yeah, I do need indices start. Indices start I do need. You set is this and detailed draw count indices spot. So basically it updates forever, and the last update. Why did I organize it this way? Because I don't really want to have special allocation or closing logic either before the loop or after the loop. This keeps it like this place here allocates stuff, and this place here just updates. The last update here is the right one. This I don't need. And the same thing basically for the and as you can see, I made a mistake there. Plus VBO offset. I really need to have the course VBO offset set to 0 here. Face vertices. Vertex force minus course VBO offset. Face vertices. C max draw vertices. And the same goes for the allocation of yeah, I completely forgot to add the vertices count here. So these need to add vertices. And this also need to add vertices. Okay, this is fine, and this basically does the same thing, just draw indices start. Yeah, this is probably correct. Expression result unused. What? Not 4. Okay. Show. Course view offset. About draw indices start. They have the same draw indices start, right? But they have different count. Indices pause minus draw indices start. What? I draw. Detailed rows count and the same here. Okay, I don't need this anymore. And I don't need render model optimize. What is this? Temp indices offset. Не, я не пробовал никуда в такие штуки заполнять анкеты. So it creates temp indices and then goes through all the draws. Temp indices plus temp indices offset. Index buffer plus t start. T count. Start temp indices of. What the hell is going on here? Indices buffer plus t start. Oh yeah. What it does here is after it creates a draw in unordered, we did sort the draws here by materials, and then we need to make these draws continuous, to have their indices continuous, and this crap is not needed anymore. I just can create temp indices. Temp indices. Yeah, we don't need any of this. We just need to create. We can use directly the indices buffer because we already sorted all the stuff by sorting faces. That's good. Minus like this weird piece of code that I spent quite a few dozens of seconds understanding what was going on there. And this thing I need to fix this. Draw indices start. Indices pause plus. Force the draw count. So yeah, this thing need to plus them. And course draw doesn't need to have the face material, but okay, let's just mark it with fix me. We need to have some other material here. And basically this should be it. I obviously made a couple of stupid mistakes there that I didn't pay attention to. Another thing that I don't really want to do here is to do VBO offset. Actually, that's because this call here is expensive. This call here is expensive. But yeah, let's try it. And to do, don't really need it. And then this thing becomes really simple because we can remove these 16 lines of code and Да, по сути, каждый кадр обновляется только матрица Model View Projection. Okay, I am currently only trying to support the detailed render. Model draw. Like, I believe this function isn't used anywhere, and I can just remove it, right? Oh no, this is the continuation of this function. Okay. But why is it made this way? Okay, let's reorganize it. Render model draw render. Okay, src render age render model optimize is not there anymore. Render model draw MVP model. Okay, let it remain this way, but I will make this static function render draw, which will only get the draw. Okay, and this should become quite a bit less complex. Oh. Detailed draw count, detailed. And render draw model detailed draws plus I, and this is 0, and this is start and count. Why do you need start and count for? Material M. Draw material. Drill base texture. Okay, set the texture, whatever. Apply a trips. Set. So yeah, you do need model. You still do need model. Construct BSP model. But you don't need to exit this. BSP draw, you already have a draw. You don't need to do no draw compare or whatever. You just need to call draw elements with model with draw count start draw start, and all of this crap goes away. Right? Right? Something like this. And another thing that needs fixing is this. Okay, let's try it. I draw model detail draws count failed. Okay, so we did create a draw that wasn't needed at some point. Well, obviously, because, well, yeah, this. It's a separate thing. Profiler cursor. Okay, let's make it just one thing. Well, nothing immediately broken here, which is a good thing. Let's try 10. Profiler cursor. Let's try to make 2 of this. And profiler cursor. So something corrupted the cursor. Another thing is, what I really want to do is void const temp cursor is stack get cursor ctx tmp. And at the very end of this function, I want to free the cursor stack. Free up to position team ctx tmp and tmp cursor. What? Yeah, probably because this should be like this. I always forget the const order and such things. But still, this is corrupted for some reason. Why are you corrupted? Okay. Okay, let's just run it. And it runs on the Rotlov profiler. Although nothing is okay, let's run it again. Cursor is 0. Okay, let's make it 32 maps. Yeah. Okay, so you just exited. Assert. Where do I have my assert thing? Abort. Okay. I don't have a way to okay, GGB break on abort. What? It doesn't work. Okay, maybe, just maybe, profiler does something different. Profiler C. Okay, it does up to assert, and up to assert is a up terminate. So yeah, a up terminate and run again. One P profiler cursor. What? Okay, I see. We were running in release mode, so there are a lot of things that are, well, can't be just accessed by debugger. How did you end up there? Okay, you really do have more than 65k calls for some reason. This is like really broken. Okay, BTF, go to render model, draw, render, draw. Go to frame 4 and just show me the model. Show me the entire so model. Model has detailed this number of rows. One coarse draw. That's fine. Draw, OpenSource Paint frame 5. Next, upload it. How many triangles do I have? Let's begin. Train station. You have one model with two. There's again around 2,000 rows and a few landmarks. And then you have next. Rows count. But why do you have so many rows? Don't face sorting like sort faces? Didn't it like do it? Okay, I really want to do this, to finish this today. Just having trouble understanding what's going on there. Maybe I just need another break. Let me just look at it a bit more and then I do a second break. Okay, let me just print. What the hell? Print F. Faces this amount to this amount. Detailed draws. CTX faces count and model detailed draws count. And then I can do map 1. View. Okay, you just 3,000 detailed draws. Как будет время, сможешь объяснить, как на пальцах, как делать блюр-эффект на шейдерах? Я что-то делал похожее на несколько месяцев назад на стримах про DOF, там тоже по сути блюр. Там не надо компьют-шейдеры, можно на... Ну, то есть на компьют-шейдерах может в некотором смысле удобнее делать, хотя я сам не пробовал. Но можно делать и на обычных шейдерах при рендеринге в текстуру. Там делается двухпроходная такая штука. PV offset. Face material isn't equal to 0. How many materials do we have? Material based texture. Vertices, geometries count. Let's wait. Vertices. Okay, let me just do another thing. Oh, how to do it? CTX %s to %s. CTX faces. Not S, but probably P. That will be more parsable. CTX faces. I face -1. Material and face material. And not exactly material, but base texture 0, and here base texture 0. Okay, and you don't like the void. Okay. And yeah, I really do need to silence this thing down.
We're 3 minutes away from signal. 1400 feet, still looking very good. We're now in the approach.
So yeah, this actually didn't work at all. It does have a lot of repetition. Like the same. Same texture. Why did that happen? So basically, this cursor didn't do anything.
1400 feet, still looking very good.
If okay, let's do it this way. If materials are equal, then return 0, otherwise return the difference between textures. Faces count, faces. Does seems to be true. Size of CTX faces. Faces count. Okay, let's just... no, I don't want to do that. That will be too verbose. Base material compare. NB. Oh yeah, of course. This was this thing. Yeah. Another stupid mistake fixed. And now I have only 162 draw calls per level, which seems good. Good. So, and I also do need to fix this thing with fix me. No, not this one. This one, but I will do it after a short break. 5-minute break. Okay, I'm back. So I need to fix this. This VBO offsets really should be on there only if we have really reached the VBO 65k vertex limit. Because otherwise it implies changing of the vertex attribute binding, which is kind of expensive. So for most, it is possible to not do this for the most draw calls. And how should I do this? Course VBO offset. I believe the VBO offset should actually be common. And int need update. Not need like update VBO offset. And this basically equals this check. А можешь рассказать про удаление невидимых полигонов? Хочу поучиться, потренироваться. Пишу растиража карт из Quake. Может, попробую сделать и на вулкане. Про удаление невидимых полигонов. Такая общая тема. Значит, первое, что... Ну, то есть, идея понятна, да? То есть, что можно не рисовать то, что можно не рисовать. Чем меньше рисуешь, тем лучше. В идеале вообще ничего не рисуешь, и игрок, и пользователь радуются. То есть, номер 0 приближения. Это то, что есть такая штука, GL, там, cool, что-то там. Ну, я просто на примере OpenGL, то, что я, это самое... GL, cool, face. Давайте там GL2. Это такая фиговина, которая позволяет определенную сторону одного треугольника не отрисовывать. То есть, если треугольник повернут от зрителя, то он не рисуется. Ну, это зависит от типа порядка его вершин. Если они в OpenGL по умолчанию, если они типа против часовой стрелки, то он рисуется, по-моему. А если по часовой стрелке, то он не рисуется. Ну, это вот управляется вот этим всем. Там еще нормаль где-то участвует. Я что-то как-то начинаю забывать детали, как именно это работает. Но суть именно такая. По-моему, да, по-моему, просто порядок типа вершин влияет. Да, нормаль просто это атрибут, который можно тащить, можно тащить. Вот. Это нулевое приближение. Следующее приближение это для мишей, то есть для наборов треугольников, определять, будут они в принципе потенциально отрисованы на экране или нет. Frustum cooling, так называемый. То есть группа мишей проверяется, она вообще попадает в конус вот этот камеры или не попадает. И просто типа на нее не вызывается никакая отрисовка, если не попадает. Есть вещи чуть похитрее, когда типа на экране много объектов, которые попадают, но одни объекты зарисовываются другими. И, ну, закрашиваются полностью и не видны. Как это называется, я не помню, к сожалению, но смысл там такой, что можно еще на этапе, тоже перед рендерингом, нарисовать очень дешевым способом какую-то вот эту всю геометрию, например, очень дешевыми шейдерами там, или как-то ее предподготовив, и посчитать, сколько пикселей от определенного меша видны. И если нисколько не видны, то можно на реальную дорогую тяжелую отрисовку это просто не вызывать. Ну вот, есть такая штука. Причем она делается миллионом разных способов. То есть способ один — это, например, рисовать, ну, то есть реально рисовать, так я и говорил, вот этот дешевый кадр на экран, можно там немножко даунскейлить его, можно там еще что-то. И способ номер 2 — рендерить, например, софтом. То есть есть специальный у Intel, по-моему, open-source какой-то, и был пример с специальным отдельным софтовым рендером, чтобы просто до GPU это все не гонять. На софте нарисовать очень дешево, не то что даже нарисовать, а реально посчитать видимые. Backface cooling это... Backface cooling — это нулевой способ, самый первый. Это когда вообще ничего не делаем, просто типа не рисуем то, что в принципе не может быть видно, то есть внутренности мишей. Вот. Возвращаясь к вырезанию невидимых объектов, которые закрашены другими, это вот софтовый рендер, который по сути просто определяет, то есть будет виден объект или нет. Тоже типа быстренько на софте там за пару миллисекунд делается. Есть еще, другой подход — это не рисовать текущий кадр, а использовать данные с предыдущего кадра. То есть по сути получается пытаться дорисовывать какие-то объекты, и если они типа не попали, то выкидывать из следующего кадра. Как там добавление устроено, я, честно говоря, плохо помню. Какой-то импостер, наверное, дешевый рисуется. Вот, и если он типа попадает в кадр, то так уж и быть, в этот кадр он будет нарисован криво и дешево, а вот в следующий кадр он уже попадет полноценно. Такое, например, примерно можно видеть хорошо на рейдже. Вот можно попробовать поиграть в Rage, или лучше посмотреть, кстати, стримы записи и попробовать поделать паузу, где игрок там сильно быстро поворачивается. Вот. И там будет явно прям видно, как те объекты, которые были не видны, сначала первые 1 или 2 кадра видны плохо, то есть типа очень с низкой детализацией, а потом они как бы детализация у них возрастает. Вот. Как бы вот такой есть подход. Как-то вот все, что я знаю из головы сходу, так вспомнилось. Okay, I was just going through possible colony optimizations in Russian, and I don't really want to repeat the same thing in English again. This was to reply to a Russian question. Okay, if update VBO offset, then yeah, print this. Print this. If I face 0, update VBO offset, or I face 0, or at this point we really do need to set it, but don't really need to update it. This is a bit cleaner, and this one is also update video offset or phase 0, and this is basically the only thing to check. Course throw. And we'll need to fix material at some point. And that's it, I think, for this fix. But I really need to fix render to not... to not pay attention to the Okay, I do need to have this function here, but then I can avoid passing model here, I believe. Yeah. This is enough. And you do need to set this, because this basically means different material. And here int equals to -1. If model view, not that, struct PSP draw, obviously const PSP draw model detailed draws plus I. If VBO offset equals to -1 or draw VBO offset isn't equal to VBO offset, then we need to update VBO offset by calling this function. And by update, and we'll then need to update VBO offset to draw VBO offset. And you are unsigned int. Okay. I can do it like this. I can do it like if I put a 0 or and that should be it. So you see the numbers. This. Yeah, and this large amount of enable vertex arrays. Yeah, and basically, yeah, 1, 3, and 3. And now we can try to do all the maps with this thing, which shouldn't be really faster, but just a sanity check that everything works. I really need... I draw model detail draw count failed. Interesting. Interesting. What was the level? Landmarks. Okay, so yeah, it's one of those maps with P3 Citadel. Yeah. 21 detailed draws. Jeffrey Dorough. So here something breaks here. I draw, you don't like this, I draw. I can, okay, let me debug 1 and make debug and signal abort. Frame 2. I draw. I face. CTX. Faces count. Okay, so you do really have another face to here. So for some reason this logic here gives a different number of I see. I see what's going on here. How does this work? Okay. So yeah, these should probably be just vertices count, and yeah, logic. I see what's going on here. Logic is the same as here. Update VBO offset, not VBO offset, but vertex pause. If vertex pause, offset, VBO offset and vertex pause also equal to 0, and then the logic here is set or I face larger than 0 and face material change. Then you go away. What the? Why? VBO offset equals to vertex pause. This is not true, and if update VBO offset, then of course not like that, like this. This is anyway. This should fix it. No. Frame 2, I draw. So the same thing happened. Did you rebuild it? Okay, you did. Okay, let me just parse this logic. PPU offset vertex pose, and yeah, vertex pose plus equal face vertices. This was missing. Wow. I don't remember seeing this. For some reason it remained hidden. This is interesting. Okay, but yeah, let's try the whole thing again. Music ended. This way I will run out of demo vibes really quick. Really fast. Or how do I say it? Okay, I do get like 30-40 FPS with it. And 5,000 draw calls instead of 18,000. And it's still the most expensive thing to do. Binding texture is also expensive. Setting uniform is expensive. So I can probably call the some microseconds from here by checking if we really need to update this uniform. As for texture, I'm not so sure. But yeah, it feels quite a bit better. And this is not the last optimization that I planned for today. I'm interested how it looks for you. For me, it's pretty smooth. For you, I think it's limited by video capture. For some reason, one of the Firefox processes eats up quite a lot of CPU. Okay. Okay, next optimization. Next optimization is do the coarse draw when there are no... when the map is too far away. And this requires changing this thing here by static render draw. How was it called? SRC BSP draw set, and this is construct model BSP model and construct BSP draw set трубы в каналах из обычных мешайте, что наполовину земли торчат. Но это часть уровня, это не объект. Я на прошлом стриме показывал эпизод 1, эпизод 2 и Portal, как он сейчас выглядит. И там реально, то есть поздние игры, у них очень много всего сделано из... как они называются? Правильный термин в source движке. Прям забыл. Ну, из объектов отдельно, из моделей. And you don't do the detail draws. You do draw set, draws count, and draw set draws. Yeah, this was mistake. С пропов моделей, да. Мичу Юкхё, привет. Я рисую вот то, что сделано из брашей. Насколько, опять же, я понимаю, как это все устроено. So, render model draw. What it should do, it should draw the level depending, pick the right draw set depending on distance from the bounding box of the what I call model here, but BSP model is not like the model that we were talking about just now. It's a level model. So distance. This thing. I believe this thing is the position of the camera. It should be like the first column of the matrix, and it's camera position, right? I forgot all linear algebra. I really need to like review it a couple of times per year because, yeah. So yeah, distance, 3f, and this should be const struct, cam pose, camera position. Let me check it. Simple cam. We call projection. Oh yeah, this is not a camera position. I do need to pass a camera position separately. Render model draw MPP element. What is element? Element is the test thing. Model. Okay, let me just add the struct avec3f cam position. Need to change function signature here. And then I need to figure out the distance to the bounding box, which is basically this is really simple. Distance, and this should be const. Basically, this is a min. Do I have a min function in my math library? Okay, I will write it this way and then fix it. This is a minimum of all three components. And first thing is camera. Position x minus a model ABB max x camera let me draw it. So we have like, let's draw the 1D state. We have a line, we have like camera position right here, we have max, and we have a min. And I need a function that will give me this, either this distance, or like if camera is here, this distance, or if camera is here, then basically anything equal or less than 0. If I pick just a minimum, like comparing to maximum, this function behaves like this. Compared to minimum, this function, like distance to minimum, behaves like this. So of those functions, I really need to return maximum. So max, this is a max of x minus m, and m minus x. This is the maximum, and then I should do a minimum of those functions. The first bit max f and model ABB min x minus camera position x, and then I should do a minimum of a minimum. This is x, y, and this is X and Z. Yeah, of course. Let me define these functions here. Static float A max F float A float B, which returns A larger than B, then A, then otherwise B, and the same thing for min, but the sign is reversed. And yeah, I forgot how to type. And then if distance is less than some magic value, we do render draw set model detailed. Otherwise we do render draw set model coarse. Okay, let's try it on the first 10 maps. Source render model. This run file. Camera position. Okay, this doesn't work. Let me then check at print debugging. Do I set the AABB properly anywhere? Yes, I do. Position X, camera position Y, camera position Z, and distance. And yeah, this is F. Okay. This doesn't look right at all. Okay, there's it happened. Probably this distance should be like less than 0 if we are outside. Let's check it this way. Yeah, it renders this thing with the wrong material. Bounding boxes need to be fixed, really. And I probably should draw bounding boxes to figure out what's going on there. And fix the material. Okay, comment this out and try to draw all maps again. And we'll look at performance. Well, for some reason nothing changed. Like, I still see those. What the hell? Like, this is not consistent with anything at all. That's rain. ABB. Oh yeah, obviously. Sure. The level has offsets, which didn't the offsets aren't updated with AABB. So how should I do it properly? Probably I should make it set model. Offset. Okay, so you update this and then this doesn't work here this way. Suk. Camera pause map. What? What? This is weird. Something ridiculous is going on. Well, at least I have like almost the full frames per second that I can have on this monitor. This is not right. Z fighting, yeah. Maru infantry, привет. Okay, I actually can fix a little bit of that fighting. Depth test. Chill depth. What's the function? Gel depth. Funk. Initial gel less. I do have gel less. Nope. It should behave correctly. Excuse me. So. This should be okay. Let me just pick a single map. Which has a really huge bounding box. Maybe the deal is that the bounding boxes are huge for some reason. This doesn't look right. Minus. Yeah, sure. All of these should be maximums. Right? Yeah. And then this is, not used. Yeah, stupid mistakes. And then yeah, this becomes this. And then I can check set a lot more maps. And disable this. Maps still have don't have the correct color. Okay, this is more like it. Okay. Here I do need some kind of guard value distance. Material here is random. But I need to fix it with average color of the material. But yeah, basically it's really fast. And there are just 70 draw calls. Then I'm going to this level, and draw calls are like 250, and it looks okay. And those levels look reasonably similar to what they are. So yeah, I really do like this. This almost works as expected, but I need to fix this distance. Probably something around like 5,000 units. Test. I need to figure out what the deal with this min testing. Test. Min test. Let's go to some crowded area with a lot of maps. I can see that there are 1,000 draw calls, but it's within performance window. Okay, yeah, something like this, but with fixed average color. And then I can start quickly positioning maps correctly. There are two maps with this city map. Okay, I think this is it for today. I will improve this rendering next time. Set the average colors, and it shouldn't pop out like that and have these weird colors. So yeah, thank you for watching. Thanks for participating in chat, and well, see you hopefully next Thursday, or even closer than that. Okay, thank you. Bye.